Hello and welcome to this Haas Tip of the Day. If you've ever had questions about programming a metric or standard tap on a mill, today's tip is for you. Programming a tap should be easy, but sometimes it can be confusing. You might have to program an inch tap or a metric tap. Today we're going to show you how to do both on a machine that's set up in inch mode, with setting 9 dimensioning set to inch. If your machine is set to millimeters, we've got a different video for you. We'll come back to this metric tap in a minute. Right now we're going to focus on writing a program for our inch tap. Now there are two critical pieces of information that our G84 tapping cycle needs. The first is our RPM, our S value. The second is our G94 inch per minute feed rate, our F value. Now for this example, we're going to use a half 13 cutting tap. The first piece in our puzzle is our RPM. We're going to go with 500 RPM for this example. For your real tap, you're going to have to get with your tap supplier and find out what speed they recommend based on your tap style, the coating on your tap, and the material being cut. The second piece to our puzzle is our feed rate, our F value. This is where we have to put on our thinking caps, but it's not hard because we've got a formula. For us, using an inch tap in inch mode, our feed rate is going to be our RPM divided by our TPI. Now what's TPI? That's our threads per inch. Where do we get that? It's right in the name of our tap. We're using a half 13 tap. 1/2 inch is the basic diameter, and 13 is our TPI. If we were using a 1/4 tap, our TPI would be 20. This formula is going to work for all of your inch taps. I'm talking about your cutting taps, your form taps, and even those NPT taps. Let's fill in the blanks. RPM, 500. We know our TPI is 13. It was written on the tap. And if we run this through a calculator, we're going to get a G94 feed rate of 38.4615 inches per minute. Now this part's important. I rounded this number out to 4 decimal places because in inch mode, we can go up to 4 decimal places. The further we carry this number, the more accurate our threads will be. Let's go ahead and write our RPM and our feed rate into our program. We're going to use S500 for this tap and material, and our G84 feed rate is going to be F38.4615. Now you might have noticed when I entered that S value that I did not use an M3. It's not necessary. The G84 cycle is going to start and stop the spindle as needed. If I add my own M3, it's just going to make the program take longer. Also, I used a G84. If we were using a left-hand tap, we wouldn't use a G84, we'd use a G74. You can look that one up in the manual. We've got our 1/2 13 inch tap threading this hole at 500 RPMs and feeding at 38.4615. That feed rate and the RPM match perfectly to give us our 13 TPI. Well, we covered our inch tap. Let's move on to the metric. Now the tap that we're using is an M12 by 1.75. We're going to go ahead and fill in our RPM here as S500. But now we come to that hard part again. What is our feed rate? We've got a formula for that. We're going to use F equals pitch times RPM divided by 25.4. Now, what is pitch? No, not that kind of pitch. When we're talking about taps, our pitch is the distance from one thread to the next. And on these metric taps, that also happens to be the distance our z-axis has to travel with each revolution. It's also known as our lead. Now, where do we get our pitch from? Lucky for me, it's actually written on my tap. M12 by 1.75. That M12 is the basic diameter, and the 1.75 is our pitch in millimeters. Let's fill in the blanks in our formula. 1.75 times 500 divided by 25.4. 1.75 is our pitch in millimeters, 500 is our RPM, and 25.4 is... Where did the 25.4 come from? Well, our pitch for a metric tap is in millimeters, and my machine is in inch mode. The 25.4 is there to convert my millimeters into inches. There are exactly 25.4 millimeters per inches, so by dividing by the 25.4, we're converting it into a feed rate that we can use. When we plug this into a calculator, we're going to get a feed rate, an inch per minute value of 34.4488. And again, because we're in inch mode, we've rounded this out to 4 decimal places. Let's plug these into my program. In this program, we're going to tap that M12 hole. On our G84 line, we're going to add in the feed rate that we just calculated, F34.4488. With that done, let's run the tap. Well, we've done it. We've programmed both a metric and an inch tap using our G84 CAN cycle. Now be sure to click on today's bonus content. We've created a tapping document that covers all the formulas we use today, as well as G95 feed per revolution tapping. We've also included links to videos that cover clearance planes, pec tapping, tapping faster with setting 130, and tapping on a machine that is set up in metric mode. Be sure to subscribe to these videos so you don't miss any of these tips as they're made. That's it, and thanks for watching this Haas Tip of the Day.